Hello, everybody, and welcome to Kubernetes in the Enterprise, Best Practices in Real-World Applications. I'm your host, Mike Vizard. Today, we're joined by Nico Ehrman, who is a Group Product Marketing Manager from Wiz, and we have William Morgan, who's the CEO of Buoyant, and we're talking about, Kubernetes adoption rates and how to secure it. So stay tuned. We got a lot of stuff coming forward here, but I'm going to jump right into the first question, which I'm going to direct over to Mr. Morgan. To what degree are you seeing Kubernetes now become something of a de facto standard in the enterprise? Because when I first met you, most people were walking around saying, a Kuber what?
Yeah. Yeah. So, Buoyant has been around for almost 10 years. And Kubernetes, incidentally, has been around for just about a little over 10 years. So we've been around since the very beginning. And you're right, in the early days, it was brand new. Nobody knew what this thing was. And I think there was a fair degree of skepticism as well. Like, is this really going to take off? Is this a thing we really need to, it's like another complicated thing we have to learn. And now, of course, 10 years later, it's in hindsight, of course, obviously, we were geniuses to all move to Kubernetes as rapidly as possible. And at Buoyant, the part of Kubernetes and kind of the reason why we've been involved since the very beginning is because we built Linkerd, which is an open source service mesh, and that was, it actually predated Kubernetes, I should say predated Kubernetes as kind of external release, and we rapidly shifted on to Kubernetes as soon as we could, kind of in anticipation of this growth. So is it a de facto standard? I kind of have an allergic reaction to that term because I've been on the receiving end of a lot of marketing from competitors saying, "Oh, de facto, we're the de facto standard. We're the de facto standard." And I think that's like it's kind of a cheap shot if you're in the marketing world to call your own product a de facto standard. That said, I do think, yes, Kubernetes is a de facto standard. At this point, it's hard to find an enterprise that uses software in any kind of, non-trivial way that it does not have some degree of Kubernetes in it. I'm sure exceptions exist. There's all sorts of, reasons why you might not want Kubernetes driving the core of your nuclear power plant and things like that, although sometimes I'm surprised. But yeah, I would say at this point, pretty much certainly every company that we interact with, and even if I'm just talking to someone out on the street and they work in the software industry, it's not a foreign word. They've heard of it, and they likely know someone who's doing something with it in their enterprise.
Nico, they usually don't call in the cybersecurity folks till somebody deploys something in a production environment, for better or worse. But are you seeing the same thing? Is there enough demand out there that folks are calling you guys up and saying, "Hey, we actually need to secure these things"?
Yes, definitely. I would say, and as William mentioned, it's like when it started like 10 years ago, and I think it's still the same today in some way, that Kubernetes looks like a little bit complex, and a lot of things are coming around Kubernetes. And of course, you have to think about security when you are dealing with it, because I would say if you just think about like, let's deploy Kubernetes somewhere, but Kubernetes is like a complete platform. I like to call it like kind of a cloud, on its own. It's like you have many, many things to deal with, the network, the identity, and many other things. And I would say that's something that you have to keep in mind when you are deploying Kubernetes. And it's even more true in the cloud itself when you are like deploying managed Kubernetes in the cloud, because you have also interaction that is possible with the cloud environment. And the thing is like, when you think about like Kubernetes, it's the new golden standard for cloud native, let's say, application, and even sometimes also virtual machine, which is like another interesting discussion with like KubeVirt and so on. But yes, it's something that we are seeing, and it's also something that we are like dealing with almost every day in terms of security.
I'm going to ask another question to William here, but what types of applications are you seeing? And I'm asking the question because some folks will say that even though Kubernetes has become a de facto standard, they're not running the traditional mission critical applications, and all of that stuff is still running on monolithic VMs, but is that changing from your perspective?
Yeah, it definitely, certainly over the past 10 years, it has changed. I think from the technical perspective, where Kubernetes historically has really shined has been in kind of the what I would call from the technical perspective, like the online services. These are services that have to respond, typically to a user's web browser or phone to an API call. We've got some limit in the number of milliseconds we can really respond before like the user gets bored or the application times out. And so in order to do those calls, you need to be able to handle those really effectively. And you're doing this in the context of, usually kind of a fast moving application where you're adding features and things like that. And maybe you've got different teams that are working together. And so you're building stuff as separate services or microservices, which that's what we used to call them. And in that context, that's kind of the world where Kubernetes started, and in the olden days, we would say, okay, if you're doing a lot of batch compute, then like Kubernetes is not great. Well, now they've added a whole bunch of batch computing capabilities. If you're doing a bunch of, arguably today, I'd say if you're running a bunch of like LLM workloads, like you're actually running inference itself, there's still a lot of friction running on Kubernetes, but there's lots of there's work that's being done on Kubernetes to kind of like capture those use cases. So you start somewhere and you kind of like add more and more capabilities. At this point, I would say certainly what we see. So from the Buoyant perspective, I mentioned we have a service mesh called Linkerd, and what Linkerd does is it adds security, it adds reliability, it adds observability to Kubernetes platforms. And so in that role, we have customers who are, I say, spanning the gamut of what they're doing with Kubernetes. We have customers who are selling like fast food online, all the way to customers who are building 911 call centers. We have customers who are shipping medical devices and like analyzing medical information, like security and compliance regulations are super, super high. And then we have other customers who are like doing building video games or building like tools that you use with video games, where like the constraints are totally different. We see just kind of a vast range of applications that all run on Kubernetes. And I think at this point the platform is pretty capable. And I think the problem that it really solves for you is it allows you to abstract yourself away from the hardware, the like pool of hardware that you actually have to run on here, in a way that is kind of significantly beyond where we were with VMs and kind of manual management of VMs. So in that context, I think it would probably be easier to list the classes of applications that are not driving adoption than the other way around.
Mm-hmm. Nico, as a follow-up to that, I think early on when we started up, everybody said we should only deploy stateless applications on Kubernetes, but it seems like over the last few years, there's been more stateful applications, which is a fancy way of saying there's data on the Kubernetes cluster now. So has that kind of changed the conversation around cybersecurity? Because, well, a lot of that data may be more sensitive than people realize.
Yeah, exactly. That's completely right. And, again, as William mentioned, that all the good stuff coming with Kubernetes was everything stateless. You can like kill the application, it restarts somewhere else. So you didn't really have, you have to build your application to support that, of course, but then the orchestrator, so Kubernetes was allowed to do like all the hard work for you on the, the orchestration of those different microservices. But then, it's like exactly as you said, we don't have only like, by the way, potential stateful like application that we can run on it, because of course we can run like database. We see more and more PostgreSQL running on top of like Kubernetes, also because now you have like all those PVC, so that those persistent volume claim that you can have. So the community added like features to support those stateful application. And then also, so based on that, of course, as soon as you are adding stateful application, you are probably adding like more sensitive data. Like for instance, as we were using the like front end or like consumer application running on top of Kubernetes. So you can think about an e-commerce or whatever. Maybe you are storing like PCI, credit card information, or like PII, like personal information on that database. And then, of course, you have now to think about, how do I secure this? And it's not only from a backup perspective and so on, in case of, I would say, for instance, like encryption of if someone can get access to it, but it's also like, how do I protect it? Because now the isolation, I would say, in Kubernetes is a little bit different, that, that you can think about versus like what you have before, with like a very physical network where you can have like a lot of firewalls and stuff in there. So that's why also service mesh is a very good way also to do some sort of micro segmentation between the different like pods, and ensure that not everybody is communicating with everybody, because that's one of the default standards, I would say, in Kubernetes. So yes, definitely is something that you have to look at. And also, I would say from that means you also need to understand from a security standpoint, and that's maybe something that could be hard sometimes. It's like, first, what is Kubernetes, and what are the things that are running in there, and how things interact between the different like pods that I have running my front end, and the other pod that I have running my back end.
All right. So, folks, we're about 10 minutes in, and our speakers have established their bona fides, we like to say. But if you have any questions or anything you want to add to this, there's a Q&A button over there that we're monitoring. So please feel free to kick in, because, I'm the moderator, but I can use all the help I can get. Hey, let's go to the next question. William, how many Kubernetes clusters are there typically in these enterprise environments? And this is a significant question, because going back to the early days, I think people thought there was going to be kind of one or two massive clusters that they were going to manage, kind of almost mainframe-like. And now it turns out that there's all these distributed clusters, and they might be only running one or two applications, and we might have a little thing called Kubernetes sprawl happening. Is that fair?
Yeah, I think the answer is 3.
3, okay. How did you come to 3?
Yeah. So before Kubernetes, I cut my teeth on the world of Mesos, and the model for Mesos was one large cluster and extreme multi-tenancy. So like we were going to do, we were going to have a large cluster that had thousands or tens of thousands of machines, and we were going to like make everything run on here, and we're going to have these kind of extreme protections so that different tenants wouldn't interfere with each other and so on. And Kubernetes took a very different approach. Again, from the Linkerd perspective, this actually, we have seen a huge evolution in people's attitudes towards running multiple Kubernetes clusters, and it's driven a bunch of product changes for us in Linkerd's capabilities. So when we saw, in the early days, we saw people trying to replicate that same Mesos approach, which is, okay, we're going to have one big cluster and we're going to have multiple tenants on there. We either saw that, or we saw kind of like the shadow IT. Hey, it's early, it's just it's early in Kubernetes adoption. Just one team, and they've got like their cluster over here. And then over the past decade or so, we've seen a big shift away from the large multi-tenant clusters into lots of different clusters, one per tenant, or into lots of different clusters for scaling reasons. The design, some of the design choices in Kubernetes make it so that many smaller clusters has less friction overall than fewer larger clusters. Not to say it's impossible, and we do have some customers who do that and make it work. It's just harder. And so, for example, one of the kind of core features, I gave a whole talk about this, by the way, at KubeCon in London earlier this year, about the evolution of some of Linkerd's features, especially around multi-cluster. So one of the core features for us is the ability to connect clusters together, the communication between them, so that if you're an application running on cluster A and you want to talk to an application that's running on cluster B, Kubernetes by itself doesn't actually provide any built-in mechanisms for really handling that. Clusters don't even know their own name. Like, they don't really have a name. So you kind of have to, build layers on top of that. That's where Linkerd comes in. And so one of the core features that we have is, if you're A and you want to talk to B, okay, well, we'll mediate that communication, and you shouldn't care if you're A, if your application A, you shouldn't care whether B is on the same cluster or a different cluster, or even halfway in between, like you're doing a migration, Linkerd will just handle that for you. So we introduced that feature in 2019, years and years ago. But the way we designed it was for the kind of the use cases that we saw, which is basically people had two clusters. If they were encountering multi-cluster challenges, it's because they had acquired another company and now you had two and you used one, or like, oh, you found another team that was also doing shadow IT. And so you'd have kind of, what we would call pet clusters. Everyone was special. Now, in the year of our Lord 2025, we're seeing customers who are designing these Kubernetes platforms. Sometimes it's a second iteration around or a third iteration. And they're like, we're going to plan for 1,000 clusters, and we're going to treat our clusters like cattle, not like pets. Okay, well now Linkerd, like multi-cluster, starts showing, it starts being under stress. And so we've had the past release or two, we've done a bunch of work to make it so that you can manage those multi-cluster links with GitOps. You can handle it where you have a flat pod network, like all these kind of variations that we're seeing. So, is there a typical case? Probably. I think if you look at the CNCF survey, when I looked at that last time, there was a typical case, and it literally was 3, but there was a huge amount of variation. And, I think what we're seeing is that median count is growing over time, because we're definitely seeing an overall shift towards more and more clusters, either for multi-tenancy or for scalability or for reliability reasons, where you have them deployed in different zones around the world. Nico, I don't know if you're seeing similar things from where you sit.
Yeah. A few things that are coming to my mind. It's like it's really also depend on the use case, because I'm thinking about all those retail shop and the edge, use case where you are dealing with a lot of like Kubernetes cluster deployed in each, could be restaurant, could be like stores or whatever, that are here to be like the brain of the store, I would say. So of course, then that means you have to deal with like thousands of different like Kubernetes cluster. And it's really interesting also to see how people now are able to manage them in some like centralized way, using many different tools that you can have to do so. And I would say, of course, like as you mentioned, all the GitHub stuff, all those things helps a lot to achieve that. But on the other hand, we're also seeing like those very large, big cluster, because Kubernetes can do that also. And as you mentioned, Kubernetes was also built in some way to do multi-tenancy, to support that. So that's also a way of doing it. So that's also what I'm seeing. But again, from a security standpoint, what is the easiest way to secure a Kubernetes cluster? Of course, if you say one app, one cluster, one team, it's easier, because then you have like only one entity to manage, I would say, for that specific team. So from an airbag perspective and all those things, it's very easy. Is it the most cost-effective way? That's something that we can discuss, of course. But on the other end, you have also like the multi-tenancy, and that's where it's become more complex, because it's all, as soon as you have multi-tenancy, and that's something that we see also in the cloud, by the way, it's like so easy to give too much permission to someone or to a service, just because, you just configure something and it's like, yes, I'm doing this, and I think it's like restricted to my namespace and so on and so forth, but it's not really the case. So that's why from a security standpoint, it's a little bit harder, of course, to secure those huge, large cluster. Because you have to have a constant monitoring of what is happening to make sure that you are not missing something if someone like deploys something new, or if had like, I would say, a change in the configuration, because it's so easy to misconfigure Kubernetes. It's like a huge beast, I would say, from that standpoint.
Yeah, it seems like this has got to be, if you are at the architect level and you're designing your Kubernetes platform, the thing you're probably really focusing on is what are the like the kind of domains, what's the security domain, like where is that encapsulated, and boundary there. So like if we have a security incident and it happens in this cluster, like how far can that spread, and is that boundary being enforced by Is it being enforced by software? Is it being enforced by the network? Is it being enforced by like Kubernetes? Is it being enforced by the service mesh? And like you point out, Nico, each of those decisions you can shift one way or another, but there's kind of a cost implication too. And so you have to do this trade-off between, okay, I could have perfect security over here by never allowing anyone to ever change anything. And, we lock our Kubernetes concrete, we spray it down with concrete. And now, our cluster is now sprayed down with concrete and we can't change anything. But obviously that's very high cost. Maybe that's even ridiculous. And on the other side, you could have free for all and like very easy to deploy quickly and no rules and no friction. And then, kind of like a very low security guarantee. So, I don't know that there's a silver bullet, but I think with most software decisions, you have to be really aware of the trade-offs, and you have to understand, what you're gonna get and how you're gonna win, and what you're gonna give up in exchange for a particular model.
And if sorry, Mike. I just wanted to ask another question to continue that discussion. And of course, I don't want to anticipate any other question that we have. But William, what do you think about something that I'm seeing also, it's like it really depends also of the maturity of the DevOps team or platform engineering team. And that's why also that depends also on the size of the cluster and how it's managed. But we are hearing more and more about IDPs for internal developer platform.
Yeah.
So, and I think I would say as a developer, if I was one, I wouldn't really care about how it runs. Is it secure, not secure? What matters to me is mainly my application. So, and does it help also from an architecture standpoint, just like from a platform engineering, like, okay, let's say we abstract everything, we give that portal, we try to secure everything, and we just give that to the developers?
I like that model a lot, because for me, when I see companies that are successful at adopting Kubernetes, it's almost always because they've adopted this kind of like platform approach, where we've got platform owners who own Kubernetes, the Linkerd, Argo CD or Flux, or like all the components to building the platform, and then we have developers. Right? And the platform team has a clearly delineated set of responsibilities, and their internal customer is a developer. So the point of a platform team is to, accelerate the developers, to enable them to do stuff without having to really understand like the gory details of what's in the platform. And the point of the developers is to write the business logic, that like powers the business, and to treat the platform as this, as a place where they can run their code. The developers have to be able to observe, monitor, be on call for the code. It's not like throw it over the wall, right? Like we've moved away from that model, right? The developers have to own the running of their code, but they don't have to own the platform. And there's a lot that you can, and I think if you do this right, an IDP can be really a powerful way of kind of having a pictorial view of like, here's the interface. Here's how you, the developer, interface with the platform. And let
me jump in here, because there's a question from the audience that's related to this. And, I believe that we made it all the way to the 24-minute mark without using the phrase AI, but here we are. One of the attendees wants to know is, will we see more usage of, I guess I'm paraphrasing, AI to manage these platforms? And then to the point of this conversation, does that mean that they don't need to know as much about Kubernetes, and maybe mere mortals called IT administrators can just manage the platform? William, you want to take a shot?
Yeah, my view is actually pretty bullish on this. I think AI can be really helpful in helping understand for Kubernetes, like platform owner, for Kubernetes operator, what is going on here? Like, what is the state? Holy crap, I've got all these components, I've got all this YAML, I can inspect, Kubernetes' pod manifests all day, but can you just tell me like what's happening here? I think AI can be hugely helpful. I don't think it absolves you at all of understanding how Kubernetes works. And, that is your job. If you are building this platform, you need to understand how this stuff works. You need to understand how to build. You need to understand how to build it. You need to understand how to keep things composable, how to not have all these interlocking pieces that you can never untangle. But I think AI can be hugely helpful in understanding what the current state is and in debugging and diagnosing things. There's so many ways where we've seen our customers go wrong, not because they're idiots, because they're not, but because you're interfacing with this super complex system through like a series of like YAML transformations. It's so easy for a human to get that wrong. It's so easy and it's so unnecessary. So many of these problems are so unnecessary. Nico, have you seen a similar thing?
Yeah. First,
security domain, right? Like all these security problems, probably so many of them are just from human beings, like putting YAML in the in the wrong level of indentation or something.
Yeah, I mean, I love YAML. I read YAML like and I speak YAML like very like fluently. I used to do Ansible a lot in my previous life, so that's why I'm very like
you were born in YAML.
Yeah, indentation. I really like that stuff. Yes, space versus tab. But anyway, from a security standpoint, it's also true that AI will help a lot, and it's already helping in some way. You have very interesting projects like MCP for Kubernetes and so on, that where you can start to ask like in plain English questions. And the thing is, like as William mentioned, I like to debug Kubernetes. I like to go and inspect all the logs that I can, because that's what I like to do. But do I want to do that? I mean, at scale, I can doing that because I'm on the product marketing side, so it's easy for me. I don't have like 1,000 nodes to deal with. But from that perspective, I would say, of course, that will help, and that already help a lot from that. For instance, you can just ask a simple question. Is my Kubernetes well configured for XYZ? Or for instance, I would like to, have a CIS benchmark, and I didn't follow it since the beginning, but I just want to understand, okay, is my Kubernetes secure in some way? And what it should be like the thing that I could do to make it better? And that's the type of question that you can definitely use AI. Or something happens, something weird. I don't know, like you see like a spike on some, like on the nodes or whatever, and you also want to have like just simple questions, say, okay, what happened? And maybe something in the log is there, and that can be, used by the AI model to give like more context and makes things easier. But as William mentioned, I truly believe that you really need to understand what you are dealing with every day. So it's not like I don't even know what Kubernetes is, and I'm gonna use AI and say I'm a Kubernetes expert, because that will never happen. And by the way, that's the same thing with security. It's not because you have AI in your tool that you're a security expert. If you don't really understand what the information that it gives you, even the context or whatever. I mean, if you don't understand exactly what the vulnerability is, or the impact it can have in the environment and so on, it's like any other tool. You can ask ChatGPT a lot of questions, but if you don't understand the answer and you just say yes, that the truth most of the time can be wrong, so it doesn't really help you.
Critical thinking is key in this.
Yeah. And that's why it's very important, that's prompt engineering, being able to ask the right question with the right context when you use AI. That's why I believe you need to know what you're talking about.
Right. William, there's a question from the audience about whether or not you should rely on one of these services from the cloud providers that kind of abstract away the complexity, or should you roll your own? And rolling your own requires maybe a deeper level of expertise. And is there a choice that people should be making there?
Yeah, I think this is always always a choice you're making in any software. Is like, okay, am I going to do this myself, or am I going to have someone else do this for me? And like, if you have someone else do this for you, then it's going to cost money, and it's not going to be done the exact way that you would have done it. And then, but maybe you get to focus on other things. And like, I think as a general answer, my advice is, you got to figure out, what are you doing? Like, what is your goal? If your goal is, for example, I'm a startup founder. My goal is like to, make Linkerd the best service mesh for, Kubernetes in the world. It already is. Okay, let's keep it the best, right? How much time, how much time and energy and creative thought do I want to spend on like managing my own Kubernetes cluster? Basically zero. Like that's incidental to me. So you get like, there's a model of like you get 3 innovation tokens. You only get a certain amount of innovation that you're actually going to do. Where do you want to spend those 3 tokens? Now, for other companies, it might be critical for you to like have full control of your Kubernetes deployment. We work with some customers who are, who have military applications, and they're literally taking these Kubernetes clusters, they're putting them in boxes, they're dropping them from airplanes onto the ground. Well, in that case, like those constraints are very, very different. And like, you're not going to rely on a cloud provider, especially a cloud provider from another country to like do that for you. Right. So I would say my general advice is, like outsource that stuff and focus on what you need to do. But if you're in a situation where that actually is, important for you, you'll know about it.
I want to jump a little bit more into the cybersecurity side of this conversation for a minute, but I think we've established that the clusters are more distributed and therefore the attack surface is probably more challenging to deal with. But there's also the implications of the stack that sits above Kubernetes, Nico. And so is this whole thing starting to become a lot more complex because there's just so many layers of this cloud native stack and we need to think beyond just the Kubernetes cluster?
Yes, you're completely right on that, and that's a very good question. The thing is, like, so I would say we have like at least 2 different layers. The one that is like, okay, I'm a platform engineer, I'm deploying Kubernetes, and I have a lot of tools that I want to have deployed in there. As Demon said, either it's an agent, either it is like to do observability with Prometheus or whatever, and I'm adding more and more stuff on my ends using most of the time like Elm coming from, like a third-party vendor, software like a vendor and so on. So that's the first thing. So I need to take care of that first. It's like, okay, how do I do like a kind of a K-bomb of my Kubernetes cluster to understand what I need to update, or if something is like vulnerable, because that can happen. As soon as you have software, at some point you can have a vulnerability. So from that perspective, from a platform engineering perspective, it's like, okay, having a good understanding of what is running, where it's coming from, if I can, go back, thinking always about GitOps, where the code is stored to, like my Elm chart and so on, and all those things, to make sure that if something is like happening in like a sensor AYZ or a package AYZ, I know exactly where I can be impacted and where I need to patch things, for instance. And the second thing is like, and that one is a little bit bigger. It's like, as soon as you develop new application based on container, you are using so many like open source libraries, or Docker, container image coming from somewhere that you never know. And, I would say supply chain attack is probably the one that we're seeing more and more these days. I mean, like the last 2-3 weeks, we had many coming around that specific topic. So from a Kubernetes standpoint and the deployment, I mean, you can have that capability to say, okay, I'm going to block things before I reach my Kubernetes environment using, for instance, admission controller and so on, and then making sure that you are not deploying things that are not, like, I would say, vulnerable or misconfigured or not untrusted, because again, the supply chain attack being one of the most important things. But the thing is, how you can deal with that at the source? That's probably one of the biggest questions that we have to answer. And so what we're seeing these days also, it's like it's popping up like a lot of, almost every day. It's like, how do I start with something that is secure from the very, very beginning? So an email that is very like minimum, with the minimum impact it can have on vulnerable software, to start to build my application on top of that, just to make sure that I'm building like something based on something that is already secured and up to date and very, very minimal, because that's what you have to deal after. And it's very, again, as you never patch a container, because it's not the way to go with the container, right? You never patch it. You have to go back to this, to the CI/CD pipeline, and even at the very beginning of the code, that's where you need to fix things. And that means you need to rely on developer to do it. That's that part of thing is like, okay, let's just start with something that is really secure at the beginning, and let's go through different like guardrails in the pipeline itself up to the last defense, the last part of the defense, which is like the deployment phase with the admission controller, to ensuring that we have nothing vulnerable that is being deployed on the Kubernetes cluster. Last thing being, of course, like you still have to monitor what is happening, because you can have like something that becomes vulnerable after the deployment, or you can even have like rogue admin or whatever, someone like who's not happy with the company or whatever, that is like hiding things or a backdoor in the environment, and you still need to see what is happening at runtime. But yes, that's why in some way it's like a lot of work you have to do up front to make sure the software stack is secure. But again, most of the time, and that's what we're seeing, even if the vulnerability is like decreasing, the number of vulnerability in the Kubernetes cluster, on the Docker image is decreasing because new processes are put in place. It's something that you always have to think about when you're building your pipeline, I would say.
Seems really hard, Nico. Do I really have to do all that? I'm just trying to run my application on Kubernetes. Why do I have to think about all these hard things?
Exactly, and that's a very good question, and that's why it has to be. And I always preach for that. It's like when I talk with DevOps or even developers, it's like, yeah, security shouldn't be an afterthought. It has to be like in your day-to-day work, in your in your mindset. But it doesn't have also to be boring and something that you don't really want to do, because it's like so painful that it will take too much time to do it. That's why and we go back to the IDP, which is like the abstraction and adding like all the best practices directly in the IDP portal. But we don't do that from the IDP standpoint. We don't really do that with the container image that we're using. So let's say, okay, on the other end, let's give you something that you will not that is already secure by design, that will work for you. You don't have to think about it. But at some point, you also have to make sure that you're not using, I don't know, like a very old Log4j version that is vulnerable, as we know it was in the past, something like that. So making sure that you're not, what is important is like, as a developer, what matters is shipping fast, because that's also what the business wants, right? Shipping fast. But on the other end, you don't want the security team to chase you every morning with like a very long spreadsheet of vulnerabilities that you have to fix. So it's trying to find the right balance. And if we can like make sure that, yeah, as a developer, you are ingrained with security, and it's just like something that it's like a no-brainer. I just do it because it's like simple, it works, and I understand also why I need to do it. And if something breaks in the pipeline, I have also all the information, thinking back to the AI and MCP and so on, to help you to say, okay, these things will be vulnerable if you deploy it, so fix it now before like it's like got rejected during the CI/CD pipeline scanning.
So Nico, is that transition actually happening? And I'm asking the question because on the one hand, you'll hear people talk about shift left and we need the DevOps teams to manage more of the security. But other folks will say, well, those are the very people that made the mistake in the first place. So we can't trust them to do that on their own. And somebody has to verify their configurations. So I need the security people involved. So where's that balance to be found?
I mean, from that perspective, I would say for me, security, and I would say building something is like should be like everyone like, how can I say that? Trying to find the right word to say it, but everybody should be on board in this. It's like not you create something and you just throw it out of the wall, as you said earlier, William. It's like, that's why from a DevOps perspective, or even developers, again, it's like when I build a pipeline, for instance, I want to have some control in there, but I don't ask the developer to build that control. The only thing that I ask them is say, okay, every time you build a pipeline, take that module that was built by security and that will like enforce the best practices, or at least audit, because that's the way also I see things. It's like educating people. The first thing is like auditing, then showing what is bad to make them aware of how they can fix things. Then we do like some workshop and so on with them, just to say, okay, now you're aware of that, so just do it before. That will be way easier. And then you fix it after, and then after you block it if it's the thing. But from a platform engineering also, every time, because it's so easy to go to, I don't know, like registry.terraform.io, download a module EKS from Terraform and just say, okay, I deployed my EKS server cluster in like 10 minutes. Yeah, is it secure? Not really. It's because a lot of default are not like unsecure. It's because it's by design, because it has to be like very open to be like to be able to use by everyone. But that's why I would say, and I've seen that in my previous life, where the security team was always onboarded in the development of those modules and said, okay, that's what you need. Okay, they just do a very brief architecture review, and they just had the security best practice in there just to make sure that it's onboarded. And then as soon as it's done, you just like, work collaboratively on like the code itself to like had the new best practices or whatever. But that's what I'm seeing, and that's how I would do it.
William, there's a question from the audience here that I think maybe I'll throw your way just for grins, but model context protocol. Somebody wants to know, where does this fit in the stack, and is it going to be everywhere, or is it going to be maybe at the service mesh level? Where does this fit, and what are people going to use it for?
Yeah, that's a great question. So far in this conversation, most of the AI that we've been talking about, use cases we've been talking about, is how do we use AI to assist us in like operating Kubernetes. But there's a whole other section of AI that's extremely interesting to me right now, which is how do we use Kubernetes to accelerate AI adoption within the organization. MCP is a protocol. We are actually adding MCP support directly to Linkerd because we believe this is kind of where things are going. The MCP is a protocol that you use to expose kind of your built-in, well, often the use cases, you use that to expose your existing API services to an AI agent. And so we have customers who are doing this today and doing very, very interesting things, doing kind of business workflows on top of these, API servers that they've already developed, but doing it through like an agentic tool, either, usually through like kind of like a natural language interface. So you can imagine, if you're running some business process where like you have to get a bunch of documents and like make sure that they comply with this thing and then send it to the customer and then get it back and have it signed. Like a lot of that can be accomplished by taking your existing APIs that you've built, and instead of like building software to do this, give the human operator an agentic, kind of interface, give them a natural language interface where they're typing and doing stuff. So people are starting to explore and really push the boundaries of how do I use AI to actually solve this problem for my business? And by AI, I think in this case, I mean generative AI, right? How do I use that to actually solve this business problem for my business? I have this infrastructure that's running on Kubernetes today. How do I use that? And that's where things, to me, get really, really interesting, because that's where protocols like MCP start getting fleshed out and used within the infrastructure. Now, MCP is a protocol. It's built on top of HTTP, but it's kind of like GraphQL. It's got its own layer of kind of application logic that's built into the communication that happens over that HTTP stream. So it's not really using HTTP response codes. It's not using like request and response. You have these long-lived connections. It's a stateful protocol. And so, if you do that today through any tool, including Linkerd, that understands HTTP, you actually won't get a lot of information about what's happening on that transaction. And the first question that anyone has when they start doing, letting agents loose in their environment is like, what are these things doing? Like, how do we monitor these things? Because you got to monitor it before you can start securing it, right? Or before you can make it reliable. The first thing you have to do is like you need visibility into that. And so we're adding MCP support into Linkerd so we can start emitting metrics and traces and things like that. So that once you have these agents deployed in your environment and they're making these calls, you can see what they're doing, and you can start attaching that to alerting rules and to other things like that. From there, of course, we can get into all the authorization policy. Like, is this agent allowed to talk to the service? Well, and what about on behalf of this user versus that user? Linkerd sits in this great enforcement point, because we sit in front of every API service and we kind of control access to it. Okay, great. That stuff is like, maybe 10% fleshed out. So a lot of this, the standard is evolving and the use cases are evolving, and the customers kind of like awareness of what they can do and what works well and what doesn't work is all evolving at the same time. So that's a whole area of generative AI that is hugely exciting to me right now. Even though it's like a different use case from like, how do I use AI to help me operate Kubernetes, which is also very interesting to talk about, but less relevant to Linkerd, I think.
Nico, follow up on that a minute, because I'm sure some cybersecurity folks are watching this and listening to what William just said, and they're probably thinking, "Oh my God, what a nightmare!"
There's no security issues with MCP or with LLMs. It's just don't worry.
No, I really so. I mean, maybe the first thing that was released right after MCP announcement was how bad it was secured from an authentication standpoint. And you had a lot of blogs, from Christian Posta and others explaining why it wasn't like super well designed from that perspective. Yeah. So, I mean, as soon as you have an authentication issue, that means like you have a big like hole in your security. Yeah. So I would say it starts with always a few things. It's like, first you need to know who is using what. So where do I have like MCP servers running, and are they like exposed, well configured, and those kind of things. So it's also what we're doing at Wiz. It's like, I mean, every time something's new popping up somewhere, we are able to discover it, and then after scan it and so on to give like the information about configuration and so on. So that, I think that's really important from that standpoint. And same for, like another thing that is important, it's like all the API keys that are used to get access to those different like LLM or generative AI like SaaS platform. Because I would say most of the time you are not really running your model like on in your infrastructure. You are relying on ChatGPT, or I mean like OpenAI, like Anthropic or whatever. And that's where also you need to understand, okay, where do I have those API? Is it like secured? What access it gives to the like the model and so on, and maybe some data and all those kind of things. So that's what you have to think when you are like dealing with those environment from a security standpoint.
Yeah, you also have to worry about what's the actual content that's being exchanged.
Exactly.
Like ultimately, it's like some LLM is generating stuff and then it's sending it to some MCP server. Okay, yes. Well, what is that stuff? Does it include card numbers? Does it include proprietary source code? Like, you really have no, from the protocol perspective, no affordances given whatsoever to like you mentioned, any kind of like non-trivial authentication besides OAuth 2, but also like what kind of communication is allowed, what content is allowed to be sent, how do you define that? Like, there's so many open, scary issues about this. And what's interesting is like those open, scary issues don't really have an immediate solution, but they're also paired with all this excitement and energy and experimentation that's happening. And so you've just opened up kind of this whole world of potential security vulnerabilities that we're all going to explore and learn about together.
Yeah. Well, that kind of brings us to the last question of the day, and we'll start with Nico. But what is your best advice to folks here as they kind of look at all these issues and the things that we described? Because on the one hand, as William noted, it's huge, interesting adventure, and it's also maybe the scariest thing anybody's looked at in their career in a while.
Yeah, so I have, I would say, few key best practices that I always recommend, and not also because I'm working at Wiz, but like in general. The first thing I would say, it's like you need to know what you have. So the first thing is like, because you don't, I mean, you can say you're secure, but if you don't know that someone is running like a shadow Kubernetes cluster somewhere, like with sensitive data of the company, and you say you think you're secure because you're not aware of that, it's like, of course, you're not really secure. So the first thing is like, yes, having like visibility of everything that is running anywhere. That's the first thing, because you need to understand like how things are working in your environment. And then that's what I said also regarding like, we need to secure from the very, very beginning. So it's like, as we are talking about GitOps, as we are talking about a lot of automation, how do we make sure that all those automation are, following the best practices of the security, which is like, I have my own standard because I'm working in a financial institution, or I have my other standard because I'm working like in manufacturing or whatever. How do I make sure that those standards are already like onboarded since day one in when I'm building those building blocks, I would say, from like the Terraform code or whatever, from the infrastructure as code and so on. And then again, I think it's something that we're seeing because you don't want to deal with vulnerability. So what is the easiest way to avoid that is, again, starting from an image that is like already secure from day one again, and without like the bare minimum packages and so on, sometimes not even live shell, just to make sure that the foundation is secure. That's what I would do. And then after, again, it's like, of course, making sure that I'm constantly monitoring how things behave, because it changes over time. You sometimes have drift in your environment because you have to do like, let's say from a platform engineer standpoint, you have a fire drill and you need to fix something very quick, so you don't have to go to the full pipeline. So you do it manually or like directly in the Kubernetes cluster itself, and that creates a drift or deviation from the best practices. The thing is like, okay, from a security standpoint, I need to be aware of that, and just having like a workflow to say, okay, now how do I remediate this back in the code to make sure that if I have to redeploy it again, I will not have to fix that same issue like after and after. So that's what I would use as the best practices. I have many others, but I don't want to take all the time.
All right, William, the converse of that equation or the question is, what do you see people doing out there that makes you shake your head and go, folks, we need to be a little bit smarter?
My advice is ignore security completely. You can always add it later. At the very, very end, you press the security button and you're fine. Yeah. No, I think if you look at the arc of software over like human history, right? It's like it's layer on top of layer on top of layer on top of layer, and the expectations. Part of the reason there is because the expectations for software are higher and higher and higher. Our expectations of software even 10 years ago were not what they are today. And so my number one piece of advice or my best practice is to be really careful in managing the amount of complexity that goes into your system. Complexity is not necessarily intrinsic. If you look at something like an iPhone or an iPad, you can give that thing to a toddler, and like the toddler is going to be, as long as they don't drop it or like go to YouTube, basically the toddler is going to be safe, right? Like, and the toddler can understand how to use this thing. Well, that's amazing given the amount of complexity that's in that device. So it is possible to achieve that, but it requires discipline, and it requires like a real awareness of like, how are these layers that I'm adding working together? Are they composable? Are they working together? Or do I have these leaky abstractions? Leaky abstractions are like the number one way where things become insecure or unreliable or hard to predict. So the whole model for us with Linkerd, the reason why Linkerd is so popular, even though there's like 100 other service meshes, is we focus really hard on simplicity. And that simplicity it's mandatory. You have to do that, because if you don't have that in place, then you end up with a system that's complex, it's unmanageable, and it's going to be insecure. No matter how many security add-ons and bolt-ons you do at the end, right? You're not going to get an actual secure system unless you design it all that way from the beginning. no matter, you know, how many like simple things you add. You can't add on simplicity later, right? Like, has to be built in from every decision you make. So that's my advice, is to be really mindful of how you're designing the system and the components you're adding together, and what the complexity surface area kind of implications are as you build that. If you can do that, then you can achieve, you know, amazing things.
All right, folks, you heard it here. No matter how cool and modern the software is, the KISS principle still applies. All right. I want to thank our guests for sharing their knowledge and insights today. And I want to thank you all for also spending some time with us. It's much appreciated. And for all those of you that asked questions, thank you for participating. And for those that we didn't get to, we will send you an email with one of our folks giving some sort of answers and directions. In the meantime, if you are interested more in Kubernetes, by all means, please go visit cloudnativenow.com and just hit search for Kubernetes. There'll be about 1 million articles that will come up. And also, if you're interested in all things AI, go to techstrong.ai and you can type in things like MCP, and all kinds of fascinating things will come up as well. With that, I want to say goodbye, and we'll see you all next time. Oh, yeah, and one more thing. There's a little survey over there on the right-hand side. If you look at the handout section, if you take a minute to fill that out, it'll help us build better content for you guys, which is kind of what we're here for in the first place. Again, we'll see you all next time.